Similarity as size transformation. So first let's go through this part and then I'll tell you where do we apply it and how does it work. Okay, you can see that there are two triangles in it. Okay, don't take it as a triangle, just take it as this, that there is a line segment PA. What is it? PA. And we produce PA to PA dash such that PA dash is double of PA. So what basically I mean is that if there is a, say, line like this, I will produce it further so that this length here is doubled. Means if this is P, this is A, this is A dash, which means PA dash is double of PA. Same thing that we do over here also. Okay, produce it and extend it, mark it B, right? Then do it again over here also, C, and do that. These lengths are different. This length is different from this one, but just we are taking is B dash is what? PB dash is double of PB, PC dash is double of PC, like that. And if you join all of these, it will form what? I mean, I haven't drawn it properly. If you join all of these here, fine, it will form a triangle like this here. Okay, so basically I meant was we have a line segment PA, we produce it to PA dash such that PA dash is 2 times PA. There's another line PB, produce it to B dash here, so that PB dash is 2 times PB, and similar way PC dash is double of PC. Now join all these points. You can see they are joined. It forms a triangle. Join this part and it forms a triangle here. Now are these two triangles similar? Yes, these two triangles are similar. Now, and how will the size differ if we have made it, this distance is what? Twice of this distance here. This distance is twice of this distance. How will the size differ? Will it also become twice? Answer is yes. But question arises how? So let's do this. We see that. Let's take that. Okay, does it not form a triangle PAB here? Can you see? PAB. Does it form a triangle? Yes. Does it form another triangle here? PA dash and B dash? Yes. If I prove these two triangles similar, then we can be able to understand that. So PA and PB here, right? Proportional. PB and PB dash are proportional. Is it okay? Angle between the two are same. So if we consider the two triangles here, say triangle PAB and triangle PA dash B dash. So they have a common angle here, both the triangles, and this side is proportional to this one. Say if it is X, this entire thing is 2X. If this is Y, the entire thing is 2Y here. So they are proportional. So we can take that as the two triangle, right? So is this triangle similar to the other one? Yes, they are similar here. Then what will happen to the side AB and A dash B? So we will see AB upon A dash B dash will be equal to PA, right, upon, okay, we are supposed to find for other one, right? So what I'll do is I'll take the other one. One second here. Fine. So basically I wanted to say that PA dash upon PA, PB dash upon PB should be equal to A dash B dash upon AB, because these two triangles are similar by AA. SAS we can also say that also, right? They are similar, so we can use this. So what do we find? That these two are proportional. We know that what is PA upon a PA? PA dash upon PA. This is 2 and this is 1. So A dash B dash upon AB will also be what? 2 is to 1. Means this is double of this one here. Is that okay? A similar way, this is also double of this one, right? Right? Considering which triangle? This triangle here and this triangle. Similar triangles. So similar way, if we consider these two sides, they also will be in the same ratio, 2 is to 1. Means this will be 2, this will be 1 here. So can we say that A dash B dash upon AB is 2 is to 1? Similar way we have got, similar way, that is equal to what? B dash C dash upon BC, and similar way A dash C dash upon AC. So all of these are equal to how much? 2 is to 1, right? Does it not mean the triangle here A dash B dash C dash is, right, the ratio of the sides of the triangle, and the other triangle here is in the ratio of 2 is to 1. So the length of this is 2 times, length of this one is 2 times, length of this one is 2 times. So can we say it has got amplified, or we can say is magnified is the right word? So yes, we use the word magnified. By what? Scale of 2. What is the word? Scale of 2 here. Because it is becoming double. You can do it with 3 times also. If it is PA is say 2 centimeter, this is 4 centimeter. Now you take it 6 centimeter, that will become 3 times. If you take it 8 centimeter, it will become 4 times. Okay, so we have transformed the size here, and that is what magnified by the scale of 2. Now we can go the opposite way around here. We can go the opposite way around here. So what we did here, now we had taken this side PA, we have taken this side PB and side PC, and we have done half of PA length. If the example is for the entire length is say 4, I have taken 2 centimeter here, so this much, and that I marked it 8 as. Similar way, if it is say 8 or maybe say 6, I will make it 3 here. If it is 8, I'll make it, okay, I will make it here 4 here, right? So what happens here? Are we not putting the points which are there, which is right less than A dash, B dash, and C dash is what? Less than PA. Okay, PA dash is less than PA by how much? Which factor of scale? Half. So when we do that, use again the similarity we can use. So we can say here, that is triangle, in the triangle ABC and A dash B dash C dash, AB upon A dash B dash, okay, we have to find A dash B dash, right? So we'll put A dash B dash first. A dash B dash by AB will be how much? This is 1 and the other one is 2, double, because we have made it double, right? So what is that factor coming as? 1 upon 2, right? Similar way, that will go for B dash C dash upon BC, that is also 1 upon 2, and the last one which we have is AC, A dash C dash upon AC, right? That will be also 1 upon 2. So what is the scale factor? We can say is not magnified, is becoming smaller. So we can say reduce. The word is reduced by scale of half. You can see that it is becoming half here. Factor scale of factor is how much? Half in it. Understood? Now, so just see whatever they have given in your book. The type of enlargement reduction. Enlargement is magnification, I would say. The right word is enlargement. Or reduction is discussed above is called, we call that is entire thing as a size transformation. What do we call it as? Size transformation. Right. Now, then comes here, in size transformation, a given figure is enlarged or reduced by a scale factor of k. General term will be k. Here we took it as 2, half. It can be any number, so k, such that the resulting figure is the image of image as and is similar to the given figure. Remember, both the triangles were similar here. Remember, in this case both the triangles were similar. This triangle and this triangle is similar, but it was enlarged or reduced. So if it is enlarged, it will be more. If it is reduced, it will be less. Given figure and the object of the pre-image here. So in size transformation, what do we have? The image of a line is, okay, what can be transformed? The length can be transferred of a line. So simple one, if there is a line here 2 centimeter, we can enlarge it, make it 4 centimeter, make it enlarge it, say 8 centimeter, right? So the length can be enlarged. And what is a factor? In this case 2 to 4, it is a factor of 2, scale factor 2. If it is 2 to 8, it is scale factor of 4 here. Image of a triangle can be transformed. The size of an image of a triangle, you must, this is what we saw in the previous example. Quadrilateral can also be done. There is a quadrilateral and it can become like this. So we should remember these two quadrilaterals are similar in shape, means whatever the angles are there will be same angle here, and the only difference is the size here can be of different. So if for example it is 2, this is 4, this is 3, this is 6, this is 4, this is 8, and this is 5, this is 10. So you can see the scale factor is what? Double. 2 times scale factor is double. Those two figures must be similar. How will this be similar? Because their corresponding angles must be equal. Second thing, that this is a smaller one, the other one is a bigger one. So we can say that two similar figures are there, and what is, by how many times the sides of those two figures are in the ratio. So that ratio we are talking about. If it is bigger one, it is enlarged. If it is smaller one, it was reduced. For this, okay, if this is the size which coming out of this one, then we can say is reduced, and if the other one is coming out from this one, we can say is enlarged. So quadrilateral. So where do we use it? We use it in maps and models, and where we will have questions based on. In fact, this ratio is already marked on every map, and we know it as a scale factor, and it is denoted by the letter K. You see, in any map you will find that there is a mentioned scale factor at the top somewhere, scale factor K, and they will mention it, like maybe they will write it 1 is to some 10,000, right? So which means if you take 1 centimeter on the scale, on the map, actual will be 10,000 centimeter, okay, or maybe more, it depends upon the size scale factor, right? Or maybe you can see somewhere is 1 centimeter on this, 1 is to 10,000 means that 1 centimeter on this map and 10,000 centimeter actual, or maybe 1 lakh also, depends. So a scale factor of a map is, say for example, 1 is to 20,000. It means you take a distance of 1 centimeter on the map, and that will be actual distance of 20,000 on the scale, so which is coming to 0.2 kilometer on the ground, actual one. So we can say the K factor is what? 1 upon 2,000, 20,000 here. So this is what where we applied. Let's see. The same principle is applicable to models also. So height of the model upon height of the object. Say for example, there is a model here, a model of a house. Okay. Now, so whatever the height of this model here, an actual house will be something different, right? Fine. So height of the model here, for example, is say is just 10 centimeter, right? And then the K factor they have given you is what? Say 20. So if it is 10, maybe 100 here. So if it's 10 centimeter, it will be 1000 centimeter over here, right? So height of the model upon height of the object will give you length of the model upon the length of the object. Even it goes to the width of the model, the width of the object. So we just said height. It can be length also. So length will be in the same proportion, and the width, this width can also be in the same proportion there. So we'll come, okay, and the scale factor is K. This is all equal to K here. We will be learning those when we start solving question. Okay, if the scale factor is K, then each side of the resulting figure is K times the corresponding sides of the given figure and the object or the pre-image. So yes, we know that 2 factor, scale factor is 2, and the length is say 4 centimeter, then it will be the actual will be 4 into 2, 8 centimeter, right? area of the resulting will be figure is k square times area. Okay, area, for example, there is a triangle and there is another triangle here. We just talked about the length of the side here. If this is 2, this will be 4 if the in the scale factor of 2 only, right? 2 into 2, 4. Now what about the area? Considering the area here is say 6 centimeters square. So how much area will that be? It will not be 12 centimeters square, right? We have to, k factor has to be squared in it, okay? Remember, so we have to use the k factor, which is 2, has to be squared. It will become 24 centimeters square. And if it is a solid, it will be 3-dimensional, and the k factor has to be cubed in it. We will come across in the question when we start solving it. So remember, for length it is just k, for area it will be k square, and for solid, which is a 3-dimensional, will be what? K cube here in it. So we will see that once we solve question. Now remember, k is greater than 1 when it is enlarged. Obviously, if it is more than 1, then only it will get enlarged. If it is less than 1, it means it's reduced, and if it is equal to 1, it means it has not changed. The size is same. In fact, they are congruent figures or congruent shapes, we can say. Okay, fine. So remember, this is important for you. Area square, volume cube, and length is k. K factor, which is mentioned there. For example, they have given you 1:2, right? So it will be, length will be 1:2, but again in area it will become square, and in volume it will become cube. So we will learn more when we start solving questions on it.